Okay, today we're gonna put everything together that we did for quadratic functions that we did so far, and we're gonna apply it to word problems. So we're gonna put everything together as far as graphing and solving by factoring. We're gonna put those two together and see how we can apply it to real world situations. So we're gonna solve quadratic word problems using standard form and also factored form. Okay, so we have a problem here. Antoine stands on a balcony and throws a ball to his dog, who is at ground level. The ball's height in meters above ground. X seconds after Antoine threw it is modeled by this equation, right? This function. So we're going to look at it first and look what we have. Okay, so here's our equation. And we're going to analyze what is it telling us first, right? So let's know what we know so far. So we did, when we graphed it, remember we identified what the A, B, and C were. So here the A is -2, B is 4, C is 24. Okay, so we know the A, B, and C. And ask the question, how high was Antoine when he threw the ball? So let's look at, what does this look like as a drawing, as a picture? So whenever in doubt, just draw a picture and see what you got. So Antoine stands on a balcony. Right, so let's say Antoine's up here. And he's going to throw a ball to his dog at ground level. The ball's height in meters above ground. So this is height in meters. X seconds. So here's your time in seconds. Okay, so that's our graph. And he threw the ball. Right, so we know from our equation, since this is x squared, it's going to be quadratic. And since your A is negative, it's going to open down. Right, so you're going to have a quadratic function that looks like that. And it hits the ground at this point where his dog is at. So from standard form, we can tell what the shape is by looking at what the A is, right? So if we know that if you have a is greater than 0, your parabola opens up. If you have an A that's less than 0, your parabola opens down. Okay, so that's what we can tell from the A. If the A is positive or negative, and we can tell that this squared, that means it's quadratic. Right, your highest power or your highest degree is 2, so it's quadratic. So you know it's opening down, so it's going to follow a quadratic path that goes down like that. Okay, then we're going to look at how high was Anton when he threw the ball. So he threw it at this point, right? And this point is your y-intercept, right? Just by looking at it, you can tell. So it's your y-intercept crosses the y-axis. So that's your y-intercept, and remember we've been talking for a while now. Your y-intercept in word problems is always your initial value. Y-intercept, initial value. So when he threw the ball, that will be your initial value, and that is always given by your C value, right? Whatever your C is, that is your y-intercept. That's your initial value. So we can tell that our y-intercept is always going to be equal to 0C. So y-intercept, which is our initial value. And our A is going to tell us if it opens up or down. So those are two things that we can see just by looking at the equation. So your y-intercept initial value is always at 0C. So your y-intercept here is going to be 0.24. Because that's our y-intercept. Okay. And you can show that just by looking at if we did h of 0. If we did h of 0, right? H of 0 be negative 2 times 0 squared plus 4 times 0 plus 24, and then your zeros is going to be 0. This is going to be 0 plus 24. So your y-intercept is 24. That's how we got 0, 24. Right, so that's our y-intercept, our initial value. So it was at 24, which means it's 24 meters. Okay, so whenever you see that, whenever it's initial value, when did you throw the ball, when did it start, how high was it when it started, that is always your initial value, which is your y-intercept. Okay, example number 2. A certain company's main source of income is selling cloth bracelets. It's cloth bracelets. The annual company's profit in thousands of dollars as a function of price of a bracelet is modeled by this equation. Right, so again, we can identify what the values are, right? So, you know, A is negative 2, B is 20, C is negative 24. We can draw a picture here. So again, we look at it, squared, it's going to be quadratic, negative in the front, that means it's going to open down, right? And you can see right here, your C is negative 24, so that's your y-intercept. Just be looking at it. So you can estimate what the graph is going to look like. So it's going to be negative 24 down here. It's going to intersect here, and it's going to go up, possibly something like this. We don't know exactly, but it's going to be something like that. And then we also know what your y-axis is. So it's annual profit. So this is your profit in thousands of dollars, right, in money. And your x-axis was as a function of price right here. So this is your price. So profit as a function of price. And your price is always money for this one, right? Dollars. So your profit as a function of price. So you want to find what is the maximum profit that the company can earn, right? And this is the keyword, maximum. So whenever you see maximum or minimum, we just look at our graph. We can always tell. So the maximum profit is going to be right here, right? Because that's the highest point, your maximum. Like we talked about maximum and minimum of quadratic functions. So we want to find what is this maximum profit right there. We need to find what is the vertex, right? What is the height of the vertex to find that maximum profit. So we need to find what the vertex is. So our vertex is your ordered pair. So your vertex, remember the x value is given by negative b over 2a. That's the x value vertex. Then the y value of your vertex is going to be f of negative b over 2a. So whenever you find that number to be, you substitute it back in the equation into your function, and that'll give you your y value. So that's your vertex here. We use negative b over 2a. So for this situation, so we're going to find the x equals negative b over 2a. We use our b, which is 20, right? So negative 2 is going to fill that out. Right, so our b is 20, our a is negative 2. And then we can calculate that. So negative 20 over negative 4, which turns out to be positive 5. So our x value of our vertex is positive 5. So here's our x value. So this is going to be 5. And to find the height, which is our vertex, we need to substitute that back in. So we get 5 something. Okay, so we're going to substitute that 5 back into our equation. So now we have p of 5 equals negative 2 parentheses squared plus 20 parentheses minus 24. And then we're going to put in our 5 and calculate it. So we get negative 2, 5 squared is 25, plus 20 times 5 is 100, minus 24 equals, so negative 50 plus 100 minus 24 is going to be 50 minus 24, which is 26. Okay, so the y value of vertex is 26 right there. So our profit, which is our height, is 26. And it's measured in thousands of dollars, so our profit is $26,000. That's the maximum. So whenever you see a maximum, minimum, find the vertex. Okay, then part B, what is the bracelet price will give you the most profit, right? So bracelet price will give you the most profit. And we already have it right here, right? So the bracelet price was 5. That was the X value. So when your price of the bracelet is $5, will give you the most profit, which is $26,000. Right? So your price is 5, will give you the most profit, which is your highest point in your graph, which is $26,000. Okay, so that's part 2 of it. So the first part is you can tell what is the quadratic, or is quadratic, squared, negative goes up or down, right? Negative is down. Your y-intercept is a c value. Your 0c, that's your initial value. That's for when it's initial value. The second part is when you find the maximum or minimum, you need to find the vertex by finding negative b over 2a, and then substitute it back in the equation to find the y value, which is the height. So we found out the b or the x is 5, your price, and then your y value is 26, so $26,000. Okay, example number 3. Fish population in a certain part of the ocean as a function of the water's temperature in degrees is modeled by this equation. Okay, so let's look at what we got. So again, A is -2, B is 40, C is -128. So again, just by looking at that, we can tell what the graph is going to be. Just by looking at our numbers. So we know that our y-intercept is going to be -128. Right, so it's going to be, say down here, -128. It's going to be a quadratic because your degree is 2. And it's going to be opening down because your a value is negative. So your graph should look possibly something like this. Right, same kind of thing. Okay, and then we can label. So we can label all values. So fish population as a function of temperature. So this is going to be population, and this is going to be temperature. So population as a function of water temperature. Then it asks you which temperature will result in no fish. So 0 population, right? So when is this graph going to equal to 0? That's what it's asking you, right? So when it's 0 population, it's going to be here and here, because those are your zeros, right? So your population will be 0 at those 2 points. Remember to find the zeros. Our equation must be equal to 0, right? So -2x squared plus 40x minus 128, and your population is 0, right? It's asking when is your population 0, so make your equation equal to 0. And then we can solve that. In order to solve that, remember we need to factor. So we factored, we divided by -2, or a common factor first. Rewrite what we got. So we get x squared minus 20x plus 64 equals 0. Then we can factor that to our factored form so that we can solve it. So for this one, we can use the x factor, right? 64 on the top, -20 on the bottom. two factors that multiply 64 add to negative 20. There's different ones. Let's try, right? We got 8 times 8. That doesn't work. That doesn't add to negative 20. You find other factors of 64. Negative 16 times negative 4. That's going to work. So negative 16 and negative 4 is our two numbers, right? Negative 16, negative 4 is our two factors. So in here we got x, x, and our two factors are going to be negative 16 and negative 4. So as our factored form, then we're going to solve it. Right? Use the zero product property. So x minus 16 equals 0, x minus 4 equals 0, and solve each one. So add 16. We got x equals 16. This one we add 4. X equals 4. Okay, so our 4 is going to be the lower one. Our 16 is going to be the higher one. When is the temperature going to result in a population of 0? It's going to be 4 degrees Celsius and 16 degrees Celsius. Right, because those two are our zeros. So we made our equation equal to 0. Okay, so those are different types of problems. We're putting it all together. Okay, so let's review. Okay, so we got our C is always our y-intercept. Right, you can tell initial value, y-intercept is our C. Our A tells us, is it going to open up or down, depending on if it's positive or negative. Right, this helps us graph it. Then we can find what is the maximum or minimum by finding the vertex using negative b over 2a, and then substituting back in the equation. So we can find what the highest point or the lowest point if it's down here. Then the next one is we find our zeros by setting our equation equal to 0 and solving it like we've been practicing. Factoring the zero product property, we have two values, 4 and 16 here, which will give us our zeros. So 4 degrees, 16 degrees will be a 0 population. So try those out. Do Khan Academy. Good luck.